Problems, these are review problems. So I'm just going to give you about 90 seconds to do exercise 1. It's a exponential equation. It's a type 1. All type 1 means is it's one you already know how to do. You're going to equate the bases in case you're looking at it and have no clue, don't remember seeing it before. Right, so these first two problems, I'm going to do the first one, and then I'm going to give you another 90 seconds or so to work the second one. When we first introduced the exponential function in section 2 of this unit, we solved these things. And so both of these, but this one that I'm pointing at that I asked you to just do, is an example of an exponential equation where we can make the base the same on the same side. So what is the base that I can use on both sides of this equation? 3. Perfect. In fact, on the left side, this first one I gave you that doesn't have too much to do, the base is already there. And then 81 can be written as 3 to what power? Okay, it's 3 to the 4th. 3 to the 4th is going to be 81. Okay, what property of the exponential function allows me to say that since these two things are equal, that must mean the exponents are equal? It's 1 to 1. Excellent. Great. That was the whole purpose. Remember our first section of this unit, we talked about 1 to 1 functions. The reason we talked about 1 to 1 functions is because they have inverses that are functions. That's what makes them delightful. And so the exponential in section 2 was an example of a 1 to 1 function. So since these two statements, these exponential statements are equal, because it's 1 to 1, we can then say the exponents have to be equal. And then I'm going to add 2 to both sides, and I get that the solution to this is 6. So here's my solution set. So maybe that jogs your memory if you were looking at that and did not know where to start. So now exercise 2 is a slightly more complicated version of the same thing. Just to give everybody a nudge, what base can I write both sides of this in terms of? 2. Yeah, 2 is going to be the best thing to use. So if you hadn't started that, convert 16 and 32 to 2 to some power. All right, 16 is how many 2's? 2 to what power? 2 times 2 is 4, 8, 16 is going to be 4, 2 to the 4th power. But don't despair, 32 is 2 to what power? There you go, we'll put the 5 in right there. Now we're going to use the power rule. It says if you have a power raised directly to another power, you can multiply. So on the left, we've got 2 to the 4 minus 4x. Don't forget to distribute. On the right, we have 2 to the 5x plus 15. Once again, just like the previous problem, now that we've done that, that's the hard work. Now we can say, okay, those exponential statements are the same, so that means that the exponents have to be the same. So I will go ahead and just equate those. And then I'm going to get all my x's on the left. I'm going to subtract the 5x. That gives me negative 9x. I'm going to subtract the 4 from both sides. When I do that, I get 11. And when I divide both sides by negative 9, we get x is 11 divided by negative 9, which means I just have a negative fraction there. So that is my solution set, negative 11 over 9. We good so far? Those two problems were both review what we've already encountered previously. Now we're on to the new stuff. So that's very exciting. I am sure as we were doing this, you were like, you know what, I hope the Perkster answers this question today. What do I do if I can't equate the bases? Great question. That's this next example that I'm going to do. So we've got this exponential statement right here. 7 to the x power is equal to 12. So I am not capable of, because it would be some sort of irrational number of making both of these base 7 or base anything else. So I need a new tactic. So this is called the type 2 equation. Our book, you can see, is super clever in how they label these. When I can't equate the bases, here's what I'm going to do. I'm going to use my properties of logarithms to solve this. So I'm just going to use the common logarithm on all these. I told you I was going to avoid, for the most part, the natural log because we haven't really introduced what e is very well in this class. So I'm going to use the common logarithm, log base 10, in order to solve this problem. So here goes. I'm going to take this and I'm going to take the logarithm of both sides. So I'm going to have the common log log of 7 to the x power on the left, and I'm going to have the common logarithm, the log of 12 on the right. Now, please keep this in mind. The log of 12, that's just a number. I don't want you to, but you could just go into your calculator and you could put in 12 and hit the log button. It's going to give me a super long decimal. We're just going to leave it like this, but just know that that's a number. That is a known quantity right there. Great. I've not done really anything terrible to this problem. In fact, here's the benefit. The reason I'm doing this is because now this x that's in the power, since this is a logarithmic statement, I can use the power rule of logarithms, and I can bring this x down to the front. And so it becomes x times log base 7 is equal to log base 12. Again, log of 7, that log of 7 is just a number. You could put it in your calculator. I don't want you to. We're going to get the exact answer, not an approximation. So now what I'm going to do is I'm going to divide both sides by the log of 7. It's just a number. They go together now. The log is not its own thing. You're not going to cancel the logs out. Okay, it's an operation. So on the left, log 7 and log 7, that's the same number, so I can cancel those two things. And so I have x is equal to, and on the right, again, both of these things are just numbers. It's a ratio. Do not cancel the log. Okay, I know the log looks the same on both sides, but that is an operation. That is not variables or anything like that. So here's the answer. The logarithm of 12 divided by the logarithm of 7. Done. So my solution set is logarithm of 12 divided by logarithm of 7. All right, if you can understand that problem, then nothing on the front page is going to cause you trouble. Okay, it's all the same sort of thing. So if you don't understand what we did on that problem, that is a great opportunity to ask a question and get it cleared up. So what I would like you to do, and if you have a question, just raise your hand, I'll answer it. On the right side of the page, do 5 to the x power is 19. All right, so once again, I have this exponential equation, which means the variables and the exponent. That's why I'm calling it that. I cannot equate the bases. They are completely different. So I'm going to take the logarithm. I'm going to use the common logarithm. The log of 5 to the x power is equal to the log of 19. Again, that's the key step. That's the new step. I'm doing that so that I can employ this property. I'm going to bring this x now down to the front. That is the power rule of logarithms. So I've got x times log of 5 is equal to log of 19. Both those logarithms are just numbers. They're constants. So I'm just about done with the problem. I'm going to divide both sides by the logarithm of 5. On the right side, or excuse me, on the left side, those are both the exact same number, logarithm of 5 and logarithm of 5, so I can cancel it. On the right side, I'm just going to leave this as the exact answer, the logarithm of 19 divided by the logarithm of 5. And that is my solution set, and I'm done. All right, before we move on to the next problem, does anyone have any question about what we just did to both sides of that and how we were able to solve it? Because the next problem I'm going to do is very similar. It's just a little more algebra, actually, just a little more introductory algebra. There's no more college algebra in this next problem. Okay, so again, it's a little bit longer. There's a little more busy work, but it's all busy work that I'm hoping you know how to do already. So here goes. Example 2. I've got another exponential equation. This time, the difference between this problem and the previous one is I've got variables on the power of both sides. Okay, so that makes it even more fun. So again, when I notice that, I'm going to take the logarithm of both sides. Okay, so that is going to be my standard practice. So I'm going to take the logarithm of 2 to the x plus 3 power is equal to the logarithm of 5 to the x. I'm going to take this slow. I'm going to do all of my algebra steps slow. I'm going to write everything out for you so that there's no cause for confusion. So if I lose you at any point, just let me know, okay? Because again, I don't think the tough part to this problem is actually the new stuff. I think it's the introductory algebra that you're going to be like, okay, I gotta remember this. So now I'm going to do the power rule. So I'm going to bring this x plus 3 to the front. So x plus 3, I'm going to put it in parentheses, times the log of 2 is equal to x times the log of 5. That right there ends the new stuff. The rest of this is going to be simplifying, just using some old introductory algebra. So what I'm going to do now, since again, log of 2, that's just a number, it's some sort of power, I am going to now distribute that. So I'm going to have x times the log of 2 plus 3 times the log of 2. All I did right there is I distributed the log of 2, whatever number that is, whatever decimal, I just distributed it through the parentheses. And now what I want to do is I want to solve this for x. So I'm going to, like any other linear equation, in fact, I'm just going to slide this back up here. I don't think anybody had any hesitation in solving this linear equation right here when we had 4 minus 4x is equal to 5x plus 15. We decided, or we've done this 1,000 times, I'm going to put all the x's on one side, I'm going to put all the numbers on the other side so I can divide. We are going to do the exact same thing with this logarithmic equation that I got. So coming back down here, I'm going to put all the x's on one side and everything without an x on the other side. So that's just one thing to move. I'm going to take this x times the log of 2, and I'm going to put it over on the right. So I'm going to subtract it. X log of 2 minus x log of 2. Trying to take this slow because I just want to make sure that even though these steps are old school steps that you've done since middle school, I don't want to lose you on this work. So if I do lose you, wave your hand. So on the left side, these two things are like terms. I've subtracted them, so they cancel, they're gone. So all that I have on the left is 3 log of 2. On the right, now here's the unfortunate thing. This is how this is a little bit different than the linear equation that we solved in exercise 2. These two things aren't like terms. Unfortunately, I cannot say, oh, log 5 minus log 2 is log 3. That's not how logarithms work, so please don't do that. So I'm just going to rewrite this. They're not like terms. So I've got x log of 5 minus x log of 2. I can still solve this. Okay, we're 2 steps from the finish line. Okay. Step number 1 is, here's what I do notice. Even though these are not like terms, they have an x in common. Okay, there's an x right here, and there's an x right here. So again, an introductory algebra concept that you've been doing forever is when there is the same thing in 2 terms, I can factor it out. So I'm going to do that. So I have 3 log 2 is equal to, I'm going to factor that x out. And when I factor the x out, I have log 5, which is just a number. There's some value. I don't care what the value is. I'm going to leave it log 5 and then minus log 2. I just want to recap, okay, because I know it's been a while. So I took the log of both sides. The reason I did that is so I can move these powers down in front of the logarithms. Now, this is just a linear equation. It just looks gross because I've got those logarithmic numbers in there. So like any linear equation, I got all the x's on one side, everything without an x on the other. Since these are not like terms, I factored out that x. And now the last step is log 5 minus log 2. Again, your calculator can tell you what number that is. It'll give you an approximation. We're going to leave that exact. So I'm just going to divide by it. And here is the answer. Here's my solution set. I'm going to be lazy, and I'm just going to write this in some set brackets right here. I've got 3 log of 2 in the top, and then I've got log of 5 minus log of 2 in the bottom. Again, that's the exact answer. Your calculator can give you an approximation, but I'm done with the problem. I've invested enough effort into it. Now, I know that takes some effort. I know it's going to take a little getting used to doing that algebra. That's why I've got 2 of these that we're going to do together. I'm going to give you like 2.5 minutes to look at exercise 4 and make as many steps as you can. If I didn't leave you enough room there, I apologize. Either work on the back or grab a piece of scratch paper or something and give yourself plenty of room. But that problem should be very, very similar to what we just did. If you need me, if there's something you're not understanding, wave your hand. I will come to you. I'm happy to help you out. I want you to do well. All right, let's see how you did so far. As we're going through this, if there's a step that got you hung up, don't be shy. Okay, let's get this out in the open so that you can go into this test we're going to have on Tuesday feeling really confident. So again, I cannot equate these bases. That is clearly the easier thing to do when it's possible, but I can't. So I'm going to take the logarithm of both sides. So I've got the logarithm 4 to the x minus 1 power, and then I've got the logarithm of 7 to the 2x power. Again, the reason we do that is we're employing the property of logarithms that says that power now can come down and be the coefficient. So I have x minus 1 times the log of 4 is equal to 2x times the log of 7. At this point, I want to stop because, again, that's the new part of the information for the day. Does anyone have a question about how we got to there? Okay, I'm trusting. There's no reason that I don't think I've ever gotten angry at a question. So I'm hoping that you're being honest with me. We're going to get out at 11:45 no matter what you do here. Okay, so ask your questions. So now I'm going to employ my algebra. I'm going to distribute the log of 4. So I've got x times the log of 4 minus 1 times the log of 4, or just log 4. On the other side, I've got 2x log 7. Okay, again, it looks gross, but that's just a linear equation. The log of 4, the log of 7, those are just numbers. They're coefficients. So in order to solve this, I've got one term to move. What term should I move in order to take a step to solve this? Yeah, I want to get all the x's on the same side. So I'm going to move that x log of 4. Great idea. So here we go, minus x log of 4, and then minus x log of 4. Great job. So on the left side, what that leaves me is negative log of 4. And on the right side, since again, those are not like terms, so don't try to combine them in any way. It's not going to work. So I've got 2x log of 7 minus x log of 4. And while some of you are getting caught up with me, I'm going to take, all I'm going to do is I'm going to take this right here and I'm going to transcribe it up over here where I have some room. So I'm not doing anything new here if you're at a place where you still have some room. So I've got negative log of 4 is equal to 2x log of 7 minus x log of 4. All right, again, I'm 2 steps from the finish line here. What is the second to last thing I have to do on this problem? Got to factor out that x. Both of those things on the right have an x, so let's factor that out. That is a great, great idea. So I factor the x out. Everything else is going to stay. All those other things are just numbers. So I have 2 times the log of 7 minus the log of 4. Oops, I got a little scrunched there at the end. I apologize. And then last but not least, I'm going to then divide. And so here is my solution set. My solution set is what I get when I divide both sides by 2 log 7 minus log 4. And I'm just going to write it in some squigglies right here. I have negative log of 4 over 2 log 7 minus log 4. I'm just going to make one note about this. That is a beautiful answer. You are completely done with that problem. No one's reported this, or at least I don't remember. I don't know how fussy my math lab is. Sometimes they don't like negatives in places that I don't care about them because there's no reason. So when you're putting your answer in, if I don't know, it might be good to do this up front, or maybe my math lab will take it either way. But this negative that's up top, it might not like that. I don't know. I've not input answers into my math lab. Okay, so if it doesn't like this negative, all you would do is change the signs of all 3 terms. Okay, so you'd have a positive up top, and then you'd have a positive log 4 and a negative 2 log 7 in the bottom. And I'm not saying my math lab does or doesn't. I'm just saying, just in case, that might be the thing it doesn't like. Okay, so just be wary. All right, so one more of these. Okay, again, this is the busy work of the day, and then the rest of what we do, most of it's not going to be as involved as this. So go ahead and solve exercise 5, another exponential equation. right, just for time's sake, I'm going to get started. So compare your work with mine. Again, if you got any questions, be aggressive, ask them, get what you need from this class. So I got an exponential equation. I can't equate those bases, so I'm going to take the log of both sides. So it's log of 2 to the 3x plus 1 power is equal to the log of 3 to the 4 minus x power. I'm now going to bring those powers down to the front. So on the left, I have 3x plus 1 times the log of 2, which is just a number, so no mystery there. And then I have 4 minus x times log of 3, so no mystery there. Only difference in this problem and the previous one is now I have x's on both sides and I have constant terms on both sides. So we're going to have to move two things in just a minute. But before that, what should I do with this? What's my next objective? I'm going to distribute. I'm going to get rid of those parentheses. So I'm going to have 3x times the log of 2 here, plus 1, or just plus log of 2. On the other side, I'm going to have 4 times the log of 3 minus x times the log of 3. I just want to pause. Is anyone conflicted up to this point? Are we doing okay? Anything that you need a question about? Okay, so I have a linear equation. Got these logarithmic numbers, so it looks worse than it is. So like any other logarithmic equation, I'm going to get the x's on one side, I'm going to get the numbers on the other. It absolutely does not matter what side you choose to do this. I'm just since I have stuff on both sides, I'm reverting back to Miss Hilliard in 10th grade, who demanded x's on the left. So I'm going to put the x's over here on the left by adding this x log of 3. If you brought the 3x log of 2 over there, that's fine. You're going to have an answer that is no different than mine. Okay, so totally fine. So I'm going to add the x log of 3. And because that's my step, then the other thing I have to move is this log 2's now got to go. It has no x in it, so I don't want it on that side. So I'm going to subtract that. So what I have on the left is 3x times the log of 2 plus x times the log of 3 is equal to, and then I've got 4 log 3 minus log 2. Lots of logs. Love to say that word. And again, we're 2 steps from the finish line. So lots of hard work, busy work. I get it. That can make you go blind if you do too many of these. I understand. I'm going to go ahead and I'm going to factor out the x on the left like we've done in the other problems. So when I do that, I have x times 3 log 2 plus log 3. On the other side, it's just patiently waiting for anything to happen. And then the last step is I'm going to divide by this number. Again, this is just a value. Okay, there's nothing unknown here. So I'm just going to divide by that value, the 3 log 2 plus log 3. And so my solution set down at the bottom, let me slide this up a little bit so those in the back can possibly see, is going to be this. I've got 4 times the log of 3 minus the log of 2. That's the top. The bottom is 3 times the log of 2 plus the log of 3. And at long last, I am finally finished. Lots of algebra busy work. I will put one of those on the test. Okay, I'm not trying to torture you. Just want to make sure you understand taking the log of both sides and solving the equation. Okay, so there's going to be a little bit of algebra busy work on the test when you take it next time. All right, so that is pretty exhaustive on exponential equations. So we're going to turn the page, and now we're going to look at logarithmic equations. So again, in fact, you already have all the tools. There's going to be nothing new here on this page. So first thing, exercise 6. When we first talked about the definition of the logarithm, we solved the problem just like this. So what I would like you to do in exercise 6 is solve that using the definition of the logarithm. definition of the logarithm. I'm going to take this logarithmic statement and I'm going to make it an exponential statement so that I can solve this equation. So what's the base? 5. What's the power? Yeah, the logarithm always produces a power. So 3 is equal to 8 minus 3x. Bam, I know how to solve that. It's a linear equation. 5 to the third, your calculator will tell you, or hopefully told you, that's 125. I'm going to subtract 8 from both sides. So when I subtract 8 from both sides, that's going to give me 117 on the left. And now I'm going to divide both sides by that -3. And what is 117 divided by -3? Anybody got that information for me? Thank you very much. Appreciate that. -39. Now, one thing you do have to be cautious of with your logarithms. Remember, logarithm has a limited domain. I don't take the logarithm of 0. I don't take the logarithm of a negative number. So a good habit to get in is always to take that number that you just got and plug it back in and make sure you're not taking the logarithm of a negative. Now, in this first one, when I take the -39, I've got -3 times -39 up here. So -3 times -39, well, that's 117. And then when I add the 8 to it, that gives me 125. So that's fine. That's a positive value. So everything is good. So that's my solution set. All right, if you can do that problem, nothing else on here should give you any sort of issue. Okay, it's the main way, 95% of the time, except for down here at the bottom too. When there's a logarithm on both sides, there's a slightly quicker and easier way to do the problem. But when you have logarithms on one side and a number on the other, you are going to use the definition. Okay, that's the way to solve a logarithmic equation. So example 3 is my example. So I just want to make sure I've covered all the bases and you feel good and confident. So my example is this. I've got log of x plus the log of x minus 21 is 2. So here's what you've got to remember, though. I've got a sum here. I can't use the definition just yet. I have to have just a single logarithm over here. So I'm going to use the properties of logarithms. So remember, logarithms produce a power. In what situation, what's the rule that produces an adding of the powers? Product rule. Yeah, so what I'm going to do is I'm going to rewrite this side right here using product rule. The product rule just says this. I've got a plus sign, so that means I have the logarithm of x times x minus 21. I multiply those two things together and I make it a single logarithm. And great, now I can use the definition, just like we did in exercise 6. So I know one's not written. What is the base of this statement? 10. This is the common logarithm. Remember, when there's no base written, the 10 is implied. So this is 10 to the second power is equal to, and if you don't mind, I'm going to go ahead and distribute just to save myself a little green ink here. So x times x is x squared. X times -21 is -21x. Well, I know we don't necessarily love them, but I know how to solve this kind of equation. It's a quadratic equation. So I'm going to get everything on the same side. So I'm going to take this 10 to the second, or 100, and I'm going to bring it over to the other side. So I got 0 is equal to x squared minus 21x minus 100. I can factor that one, and I'm going to, but if you don't like factoring and you just want to jump straight to the quadratic formula, go for it. This is great review because in a couple of weeks, I think like 3 weeks, we've got a final exam coming up. So solving quadratic equations is going to be on that final exam. So it's good to remember. So I'm going to factor this one. So x squared is x and x. The two factors of -100 that are going to add up to -21 are, anybody got those for me? Yeah, 25 and 4, and we're going to make the 25 negative and the 4 positive. That's a 25. It does kind of look like a 15, but we'll make it look a little better. So that means I have x minus 25 equals 0 or x plus 4 equals 0. Hopefully you've solved enough quadratic equations in your life that this is sort of looking familiar. And so I have two possible answers, but of course I have to check them and make sure they fit in my domain. So either 25 can be an answer or -4 can be an answer. So all I'm going to do now is I'm going to go back and I'm going to make sure, do both of those give me positive values inside my logarithm? So the 25, I have the log of 25. Is that taking the logarithm of a positive? So far, so good. Over here, 25 minus 21 is 4. That's log of 4. Is that taking the logarithm of a positive? Yeah, we're good to go. 25 is a fine answer. Let's look at the other one, -4. When I put -4 in right here, I have the log of -4. Is that taking the logarithm of a positive? No. See you later. I'm done with you. So there we go. The solution set is just 25. The next 4 problems are all very similar to that. We're just going to do them one at a time. Again, my offer to you is please, if you have a question, don't sit there like a stick in the mud. Ask your question. Make sure you leave here at least feeling settled. Do exercise 7. It's super similar to what we just did. You're just running through the steps now. Okay, so just to make sure we're all on the same page, I'm going to get started on this one. So again, I've got a plus sign. It's another product rule problem. So the first step is I've got to take these two logarithms that are on the left and make them a single logarithm. And again, my whole reason for doing this is I want to use the definition. That's really the only thing at my disposal to solve 95% of these logarithmic equations you're going to encounter. So on the left side, I have the log base 2 now of x minus 7 times x. On the other side, I have 3. That has not changed. So there we go. There's step 1. Step 2 is now I'm going to use the definition of the logarithm. So my base is 2. My exponent is 3. And on the other side, I'm just going to go ahead and do that multiplication. So x times x minus 7 is x squared minus 7x. Let me stop, because again, that's the new stuff. That's the stuff that's relevant to logarithms and all this. Does anyone have a question about how I got from the beginning of the problem to there? All right, well, then I'm going to go ahead and finish. It's a quadratic again. It's going to factor. In fact, I make most of these factor unless I make some sort of mistake with the numbers. So 2 to the third is 8. So I'm going to subtract that 8 and get x squared minus 7x minus 8. I'm going to factor that. The two factors of -8 that are going to add up to -7 are -8 and +1. I'm going to take each of those individual factors and I'm going to set them equal to 0. And I get that either x is equal to 8 or x is equal to -1. So again, just going to check those real quick, make sure they're in the domain of my original logarithms before I bid farewell to this problem. So when I put 8 in, 8 minus 7 is 1. That's a positive number. That's great. When I plug 8 in here, that's a positive number. So this one works out just fine. When I do -1, -1 minus 7 is -8. That's bad. That's a negative number. So I'm going to throw that one away. And so my solution set just has one value in it, 8. Again, if you have a question, ask it. If not, move on to exercise 8. It's again the same sort of thing we've just done twice. Third time's a charm, as the expression goes. All right, I'm going to get started on this one. Again, there's a plus between them, so it's another product rule problem. So just kind of drilling this into your head right now. So I'm going to apply the product rule here on the left side of this in order to combine those logs into one single one. So I have the log base 9, that's a 9, not a g, of x minus 5 times x plus 3. So I'm multiplying those together is equal to 1. Again, once you have a single logarithm, you apply the definition. So I have the base 9, my exponent is 1. And on the other side, again, I'm just going to go ahead and FOIL those together to save me a little room here. If you had to do that separately, that's fine. But when I do it, I have x squared minus 2x minus 15. Again, third time in a row. Got a quadratic. The next one won't be a quadratic, so you get a little break from doing this for a problem. So I'm going to go ahead and bring the 9 over. So I get x squared minus 2x minus 24. I can go ahead and factor that. The two factors of negative 24 that are going to add up to negative 2 are negative 6 and plus 4. Take each of those factors, set them equal to 0. Again, solving the quadratics, if that's mysterious, if you never got that, then we should talk, because there's a couple of those on the final exam, and I don't want you to be left behind on those problems. And so we get these two possible solutions, 6 and negative 4. When I check them, 6 makes both of those positive. It works out. Negative 4 makes both negative. So I'll throw it out. And so my solution is 6. All right, the next two problems make one small change to what we've been doing. In exercise 9, before you get going, what is the one difference in exercise 9 than the previous 3 problems we've done? There's a minus. What does the minus mean? What's the rule that I'm going to use to combine those into a single log? Quotient rule. Go ahead and give it a try. Do your best job. All right, this one's a quotient rule problem. You already identified that for me, so great job. I appreciate that. So just like with the other problems, I'm gonna combine that left-hand side into a single log. So I have the log base 2, but this time, instead of multiplying them, I'm gonna have an x plus 5 in the top and an x minus 2 in the bottom. We are gonna divide those two things. Quotient rule equals 3. I'm now going to apply the property of, the definition of logarithm to this, just like we did before. So my exponent is 2, or sorry, no, it's not. My base is 2, that's the right word. My base is 2, my exponent is 3, and on the other side, we just have the x plus 5 over x minus 2. Well, again, I like this because it helps us review some of these basic things that we've been talking about. I have a fraction over here. What do I want to do to both sides of this in order to solve this equation? I'm sorry, what'd you say? Did you say multiply by the denominator? All right, I had trouble hearing, but I think we're on the right target there. So we're going to multiply by the denominator. Excellent. The reason we do that, remember, is we're clearing that fraction. We don't want the denominator because it's gross and ugly and we don't know what to do with it. So we're just going to get rid of it. So on the right side, the x minus 2's cancel and I have x plus 5. On the other side, I have x minus 2 times 8, which becomes 8x minus 16. I'm going to subtract the x from both sides. So when I subtract the x, I have 7x. I'm going to add the 16 to both sides and get 21. And then I end up with an answer of 3. When I put 3 into both of these logarithms, it comes out positive. It checks out as a great answer. So there we go. There's my solution set 3. The next one is another quotient rule problem. Again, if you have a question, ask it. I'm just moving on because everybody kind of seems kind of tired today. I get it. It's end of the semester. Before you do this problem right here, notice you've got a 2 in front of that first logarithm. So before you apply the quotient rule, you've got to resolve that 2 and make it an exponent on that logarithm, okay? So you're going to apply the power rule to this logarithm, and then you're going to combine both of these into 1. So give that a try. I'm going to give you a couple minutes to make as much progress as you possibly can. And then we'll hit our last style of problem. You're almost done with me for the day and the week. Right, so just in case you didn't understand what I meant about the coefficient, this 2, I went ahead and wrote that step down. The 2, we bring it up by the power rule, it becomes x squared in that first term. Now I'm going to deal with this minus sign, the quotient rule. So I'm going to have the log base 4, x squared in the top, x minus 1 in the bottom, equals 1. Use the definition of the logarithm. Every one of these has been definition of logarithm. So I've got my base is 4, my exponent is 1, and then I have x squared over x minus 1. Same question as before. How do I resolve this? I'm going to multiply by the denominator. So I'm going to multiply by that x minus 1, which I do. When I multiply by the x minus 1 on the right, I'm just left with x squared. So that's nice. And on the left, I have 4 times x is 4x. 4 times negative 1 is negative 4. Yet again, a quadratic equation. Okay, in the final 2 problems, there's one more quadratic, there's one more linear. So we'll get to that. Bless you. So what I'm going to do is I'm going to bring everything over to the same side as the x squared. So I'm going to subtract the 4x. So I'm going to have x squared minus 4x. I'm going to add the 4. While you're catching up with me, I'm just going to take this equation. I'm going to transcribe it up here. I'm not doing anything new. I'm just giving myself some room. So now what I'm going to do is factor that. The 2 factors of 4 that add up to negative 4. Well, this is nice. It's just minus 2 and minus 2. So there's less to worry about right there. And so my only solution is going to be what makes x minus 2 0, which is 2. When you check that out, it makes positive numbers in my logarithm statements. So that is good. And there's my solution set 2. All right, I've got one more, you've got one more, and then we're all going to be happy that the weekend starts. I'm going to do example 4. Your problem's actually easier than mine, so you're welcome. So this one, notice this problem right here. I've got logarithms on both sides of the equal sign. Now you could, if you felt like it, you could bring all the logarithms over to the same side and use the properties and the definition. That's way too much work. We can do this in a little less work than that. So in the situation when we have logs on the same side, so I'm just going to write in parentheses, we have logarithms if I can spell logarithms on both sides. Okay, that's what's different about this problem. It's a slightly easier situation. I just wanted to make sure to cover all the bases before I set you free. What I'm going to do first is I'm going to combine these two like I have been doing. So on the left, I have the log base 3 of x plus 6 divided by x plus 2 is equal to the log base 3 of x. Well, just like on the previous page, when we had exponentials on both sides that we could have the same base, and the exponential was 1 to 1. So we said, oh, if the bases are the same, then the powers have to be the same. The logarithm's the same thing. Logarithm's a 1-to-1 function. So if you have a logarithm of the same base on both sides, then you don't have to worry about the logarithm. If these two statements are going to be the same, then that means x plus 6 over x plus 2 has to equal x. And over here, I'm just going to write a little asterisk. So when you're looking at your notes and you're like, why in the world did the Berkster do that? And the reason I can do that is because the logarithm is a 1-to-1 function. So I'm just taking advantage of that property. Again, from here on out, this is not new. It might be difficult, but it's not new. I'm going to solve this rational equation by multiplying by the common denominator, which is just x plus 2. When I do that on the left, the x plus 2's go bye-bye. I've got x plus 6 is equal to, on the right, I distribute. I've got x squared plus 2x. Yet another quadratic, but this is the last one for the day. I'm going to put everything over there on the right side with the squared. So that means I'm going to subtract x from both sides. So when I do that, I have plus x. I'm going to subtract the 6 from both sides. I can factor that. The two factors of -6 that add up to +1. Even though I've had all these quadratics, I definitely haven't made the numbers too terrible. +3 and -2. And so that gives me two potential solutions. I've got the potential solution -3. I've got the potential solution 2. And let's just check them to see if one or both or neither are going to work. So when I do the -3, the -3 up here, well, the first logarithm's fine. But when I put the -3, the second logarithm's bad. Remember, I can't take the logarithm of a negative number, and -3 plus 2 is -1. Bad logarithm. And when I put 2 in there, 2 plus 6 is 8. That's fantastic. 2 plus 2 is 4. That's fantastic. 2 is positive. Fantastic. So my solution set is just the 2. All right, that was my last problem for the day. Your last problem is right beside it. So same sort of thing, except yours is not going to end up being a quadratic equation. So it should take a little less time to do. All right, so one more time, I've got a quotient rule problem. So on the left side, I'm going to say, okay, this is the natural log of x minus 3 over x minus 5. On the right side, I've got natural log of 5. And once again, this is the situation where I have a logarithm on both sides. So what I'm just going to do now is I'm going to say this is a one-to-one function. So these two things are equal if and only if x minus 3 over x minus 5 equals 5. To solve that, I'm going to multiply by the common denominator. That is x minus 5 on both sides. On the left, those x minus 5s cancel, and I got x minus 3. On the right, I've got 5x minus 25. And so I'm going to bring my 5x over by subtracting it. I get negative 4x over here. I'm going to add 3. When I add 3, I get minus 22. And when I divide both sides by negative 4, I get negative 22 over negative 4. Which is really, when I reduce it, positive 11 over 2, or 5.5. And you can check 5.5 is going to leave all of these logarithms positive. So that is a lovely, lovely solution. And I'm done with that problem. All right, like I said,